Alright, so Unit 3 was Euclidean geometry. So that's going to be our wordy unit. Okay, so we're going to start with some terms. So some things we need to know are undefined terms. So undefined terms, those are basic building blocks of geometry. Geometry. But you need to know that anytime you see the word undefined terms in a question, they're talking about points, lines, and planes. Those are the most basic things. That's what everything in geometry is made up of. Okay, so my undefined terms are points, lines, and planes. Now, postulate. We use postulates in the 6th unit when we were talking about triangle congruence. But what is a postulate? So a postulate is a statement taken to be true without proof. Okay, so a postulate is a statement taken to be true without proof. Then a conjecture would be a guess. Okay, so that's going to be where I'm going to guesstimate. A guess made by looking at a pattern. Okay, so anytime a situation arises where you're making a guess about something based on what you see as a pattern and not actual proof, that's going to be a conjecture. Okay, so no proof, we're looking at patterns. And then theorem. A theorem is going to be proven true. Something that has been proven true. Okay, so a theorem, it has an actual mathematical proof to it. Okay, so someone a long time ago totally proved it's completely true for whatever amount that's in your theorem. Okay, so keep that in mind, know what the difference between these are. Okay, now we got into logic statements. So the first thing I want to write, it's not on here, but you need to know which one it is. So a conditional statement. That's our original statement. No, that's probably spelled wrong. Sorry. Original statement. That's an if-then form. If P, then Q. If P, then Q form. Remember, P is my hypothesis, and Q is my conclusion. Okay? So that's my conditional statement. That's my original. So then I get into converse. So converse is when I'm going to switch it. I'm going to switch my original statement. Okay? I'm going to switch my conditional statement. So instead of if P, then Q, it's going to be if Q, then P. Okay? So my P is going to be anything after the if and before the then. So my P is going to be two angles are alternate interior angles. So that's my P. It's my hypothesis. And my conclusion is going to be everything after the then. So then they have a sum of 180 degrees. So that's going to be my Q. Okay. So all we're going to do is we're going to split them. Now you might have to rearrange the wording a little bit just so it makes grammatical sense. But that's okay. And then on the test, it'll be multiple choice for you. So you just have to look for the one that's been switched. So for this one, my original statement is if two angles are alternate interior angles, then they have a sum of 180. So I'm going to borrow this two angles thing here. And I'm going to say if two angles have a sum of 180 degrees, then they are alternate interior angles. Okay, and so that would be my converse of my original statement. Okay, so the next one is inverse. So inverse is going to be the nots. Okay, so instead of if P then Q, it's going to now be if not P, then not Q. Okay, so that'll be inverse. So notice they didn't switch here, just the knots. It's just like the original order, but we just add knots. So here is my hypothesis, and here's my conclusion. Okay, the same statement. Now we're just going to write it as an inverse. Okay, so if two angles are not alternate interior angles, then they do not have a sum of 180 degrees. Okay, so again, we didn't change the order. All we did was put in a not, okay, for each part. So I put in a not for my hypothesis, and I put a not in for my conclusion, okay? So that's all we do for inverse. Now, contrapositive is going to be where we do both things. So contrapositive, that is both. That is going to be if not Q, then not P. Okay, so not only did we add knots, but we also switch their position. So again, the same statement. If two angles are alternate interior angles, then they have a sum of 180 degrees. So we're going to change that to if two angles, and I'm going to switch it. So if two angles do not have a sum of 180 degrees, then they do not, they are not alternate interior angles. Okay, so I did both switch and I put a not, okay, for my contrapositive. So converse is switch, inverse is not, and contrapositive is both. All right, so this last one is a biconditional statement, okay? So a biconditional statement. So a biconditional statement is saying we're going to have the conditional statement and the converse are going to be true. So conditional plus converse are true. Now, biconditional statements are also going to be in the P, if, and only if Q, because we were combining the conditional statement and the converse statement. So my conditional statement is if today is Monday, then tomorrow is Tuesday. My converse would be if tomorrow is Tuesday, then today is Monday. Both of those statements are true, so I can make a biconditional statement. So I'm going to go ahead and say that today is Monday is my hypothesis, and then tomorrow is Tuesday is my conclusion. So my biconditional statement is going to be my hypothesis my hypothesis first. So today is Monday. Then I'm going to do that if and only if. If and only if, and then my conclusion. Tomorrow is Tuesday. Okay, so biconditional statements should be easy to pick out because they're the only ones that will have this if and only if in the middle. So if it has if and only if, you're looking at a biconditional statement. Okay, So the next thing we're going to talk about is counterexamples. Okay, so a counterexample is basically an example that shows my statement is false. So it would be a true statement, true example, that shows statement is false. Okay, so it says name a counterexample for the following statement. If two angles have a sum of 180 degrees, then they form a linear pair. Okay, so a linear pair is an example of supplementary angles, because remember, if they add up to 180, that's supplementary. But we have a whole bunch of different other kind of supplementary angles. It didn't say anything about them having to be right next to each other, because that's what a linear pair is, right? A linear pair is if I have these two angles here, 1 and 2, that would be a linear pair. They're right next to each other. But we have same side interior angles, right? So if here are my parallel lines, this angle and this angle, those would be supplementary to each other. So I can say that a counterexample, I can say same side interior angles would be a counterexample to this statement, something that shows that this statement is not necessarily true. Okay, so it's not the only way that could be my statement. You could do same side exterior angles. You could do anything that adds up to, makes it two angles that are a sum of 180 degrees. Okay, so, and then right here. Now, which pairs of statements are always logically true? Okay, so remember, logically true is exactly what it sounds like, right? It's going to be where my conclusion is true. Okay. Okay, so where my statement becomes true, because that's when my statement becomes true. So, if my conditional statement is true, my contrapositive will always be true. Okay, so these will always go together. If my conditional statement is true, then my contrapositive is true as well. If my conditional statement is false, then my contrapositive is false. Okay, so logically true, they have the same truth value. Same truth value. Sorry, truth value. That's what I mean. Okay, so same truth value. So truth value is just saying whether it's true or false. Okay, so logically true is saying that they are the same truth value. So if conditional statement is true, then contrapositive is true. If conditional statement is false, then the contrapositive is also false. So the same thing goes for my converse and my inverse. The converse, if the converse is true, the inverse also is true. And if the converse is false, then the inverse is also false. Okay, so the conditional statement and the contrapositive are logically true, and the converse and inverse are also logically true. Okay? And then last question for Unit 3. What kinds of statements can form a biconditional statement when they are both true? I already touched on this before. So a biconditional statement can only be made if you have the converse. The converse. So the conditional statement first, though. Conditional statement and the converse must be true. And from the question before, you know that if the conditional is true, then that means the contrapositive is also true. And if the converse is true, then the inverse must also be true. So we can only basically write a biconditional statement if all my statements are true. But you only have to worry about the conditional statement and my converse, okay? So remember, biconditional is that if and only if. Okay, so that's P, if and only if Q. So anytime you see if and only if, that's going to be your biconditional statement, okay? All right, and that is the end of Unit 3.